We all hate math. Take it from Anna here. Somehow, in the mindless hours of her scrolling through TikTok, 1 plus 2 became the nightmarish integral of sine 3x.
What even is a derivative?
Once upon a time, hell had a name, and it was literally hell. My high school math teacher, Miss Hell, preached that the derivative, or in mathematical terms, solving for dy over dx, was simply the slope. To understand this, let's rewind all the way back to the prehistorics, a graph and its line, or the dreaded y equals mx plus b we call slope-intercept form. If you remember, the m stands for slope, aka what Miss Hell preached was the derivative. That's because with any equation with only one variable, in most cases x, where that variable is raised to the first power, the derivative is the coefficient of the variable. Visually, by solving for dy over dx, we get m. The derivative is the slope.
Wait, so you take the derivative of both sides and b just disappears?
Correct. You now know the derivative of a variable raised to the first power is its coefficient. With constants, we assume there actually is a variable. It's just raised to the 0 power, which makes the variable equal to 1. Since we proved the derivative is the slope, we know the slope of any equation y equals a constant is 0 because the graph is a horizontal line. So b, being a constant, has a derivative of 0 and disappears as well.
Okay, so using that logic, can we find the slope of any graph that isn't a line, like a parabola?
Well, yes. Take, for example, the equation y equals 3x squared plus 6x plus 2. When we solve for the derivative, we differentiate each term of the polynomial. However, you may notice 3x squared is unusual. Don't fret, the solution is easy. When you take the derivative of a term whose variable is raised to a power greater than 1, multiply the exponent by the coefficient for the new term's coefficient, and then subtract the variable's exponent by 1. The result here, 6x. The next two terms work exactly like mx plus b. The derivative of 6x is the coefficient 6, and the derivative of 2 is 0. Now we have our derivative, 6x plus 6.
Wait a minute, 6x plus 6 is not a slope. I'm confused. Trisha paid to save us.
And that's exactly why the derivative is so powerful. You see, with graphs of anything other than a line, the slope changes from point to point, something that can't be pinned down by any formula like y equals mx plus b. With something like dy over dx equals 6x plus 6, you can pinpoint the slope of the parabola at any given location.
Yeah, I bet you can't even find the slope when x equals 5,000. You can't even draw a graph that big. So maybe we don't need a graph. If we plug 5,000 into x and do the operations, we get dy over dx, which equals to 30,006.
And you, my friend, just solved a derivative.
Graph that isn't a line. Logic. Why would you laugh?
Okay.